Good morning to one and all. Our next topic is virtualization structures or tools and mechanisms. Okay, now we have seen the virtualization structure. It's a very important concept, Amma. Listen carefully, all of you. In general, there are three typical classes of virtual machine architectures. How many classes there are? Three typical classes of virtual machine architecture. Okay, here the figure showed the architecture of a mission before and after virtualization. What figure you have to ask me? What figure? Traditional operating system. Okay, traditional operating system, we have application and host operating system and hardware. In the sense, in that figure, application, host operating system, hardware, which figure that one? Generally traditional computer architecture involve applications, host operating systems and hardware. That shows you the architecture of a mission before and after virtualization. In the sense, after virtualization you have to use different user applications managed by their own operating system, nothing but guest operating system. It can run on the same hardware and independent of the host operating system. This is oftenly done by adding additional softwares, like nothing but we want to say virtualization layer. Okay, here virtualization layer, we want to we want to call one more name in virtualization layer. It is nothing but hypervisor or virtual mission monitor. Okay, in virtual missions, we have shown in that like traditional computer architecture, after virtualization we have seen the applications, guest operating systems and hardware, where applications run with their own guest operating systems over the virtualized CPU and memory and IO devices. This is the concept of traditional computer architecture. We have discussed before, after virtualization. One coming to the before virtualization, the operating system, it manages the hardware completely. And coming to the after virtualization, a virtualization layer is inserted between the hardware and the operating system, where we have to insert it between the hardware and the operating system. In such a case, the virtualization layer is responsible for converting the portions. Okay, here the virtualization layer is also known as hypervision, or one more name virtual mission monitor. It is responsible for converting the portions of the real hardware into virtual hardware. Okay, you first of all the converted into real hardware, and then it converted into virtual hardware, and therefore we have to see different operating systems. Okay, how the operating system such as Linux and Windows. Okay, it can run on same physical mission. What ma? It can run on same physical mission simultaneously. Accordingly, it can done. Okay, depending on what the position of virtualization layer it will be. There are, we seen several classes of virtual machine architectures. How many classes? There are several. In the sense, so many classes of virtual machine architectures, like namely hypervisor architecture, and coming to the topic para virtualization, and one more name host based virtualization. These are all are, we want to, depending on the positions what the virtualization layer it will be. There are several classes of virtual machine architectures, namely like we want to discuss here hypervisor architecture, and then para virtualization, and then we have discussed host based virtualization. Okay, here the hypervisor is also known as the virtual mission monitor. Here we have to learn one more name of hypervision is also known as virtual vision monitor. They both perform the same virtualization operations. Okay, coming, we have discussed here what is hypervisor and Zen architecture. First of all, we have to discuss what is a hypervisor. Is nothing but a virtual mission. It's nothing but it's a hardware. Okay, Yeah, listen carefully, all of you. A hypervisor is a hardware virtualization technique allowing multiple operating systems called guest operating system to run on a host mission. This is also called the virtual mission monitor. Okay, what does exactly I want to say in the sense? Hypervisor, it is a hardware virtualization technique, in the sense it supports hardware level virtualization. Okay, like devices like which devices like CPU, memory, and disk operating system and network interfaces. Okay, and it allowing multiple operating systems. Okay, it is called nothing but guest operating system we want to run on a host mission. Hypervisor is also known as virtual mission monitor. What does it exactly says in the sense hypervisor? The hypervisor supports hardware level virtualization. Okay, the hypervisor software sits directly between physical hardware and its operating system. Once again, I have to repeat this. The hypervisor software sits directly between physical hardware and its operating system. So this virtualization layer is referred to as either virtual mission monitor or hypervisor. Okay, what we want to say, the name of this virtualization layer is referred to as either virtual mission monitor or hypervisor. Okay, and then here hypervisor provides hypercalls for guest operating systems and applications. It depending on the functionality. A hypervisor, it can assume a microkernel architecture like Microsoft Hyper-V. Okay, or we can assume a monolithic hypervisor architecture like a virtual missionware for server virtualization. Okay, here what does I want to say, in the sense we have two types of hypervisors. First one is a bare metal. Here bare metal, it sits on the bare metal computer hardware like the CPU and memory, etc. In the nothing but storage devices. And coming to the in type 1, all guest operating systems are a layer above the hypervisor. Okay, so the original CP or CMS hypervisor developed by IBM software was of this kind. Okay, and coming to the type 2. Type 2, in the sense it's nothing but a hosted hypervisor. What is the meaning of the hosted hypervisor? In the sense it run over a host operating system. So the hypervisor is the second layer of the second layer over the hardware. So the guest operating system runs a layer over the hypervisor. So the operating system is usually run aware of the virtualization. What exactly we want to say, in the sense a microkernel hypervisor includes only the basic and unchanging functions like physical memory management and processor scheduling. So the device drivers and other changeable components are outside hypervisor. So a monolithic hypervisor implements all the functions and including those of device drivers. Therefore the size of hypervisor code of a microkernel hypervisor is smaller than that of a monolithic hypervisor. Essentially, a hypervisor, it must be able to convert the physical devices into virtual resources dedicated for we want to deploy virtual mission what we want to use. Okay, once again I have to clear cutly I want to discuss that. First of all, you have to assume a monolithic hypervisor architecture like virtual mission software. A microkernel hypervisor, it includes only the basic and unchanging functions like physical memory management and processor scheduling. And coming to the device drivers and other components are outside hypervisor. So a monolithic hypervisor implements all the functions and including those of device drivers. Therefore, the size of a hypervisor code of a microkernel hypervisor is smaller than that of a monolithic hypervisor. Essentially, we have to say what does exactly it means. In the sense, a hypervisor must be able to convert physical devices into virtual resources dedicated for deployed virtual mission what we want to use. And coming to the Zen architecture, okay, what does mean Zen architecture? This is the architecture we have to shown. This is the Zen architect. This is the Zen architecture's special domain wo for control and input and output, and several guest domains for user applications. What does it means exactly Zen architecture? In the sense, we want to say Zen is an open source hypervisor program developed by Cambridge University. Okay, it's an open source hypervisor program. It is a microkernel hypervisor which separates the policies, what mechanisms from the mechanisms. Zen hypervisor implements all mechanisms by leaving the policy to be handled by domain O. Okay, as shown in the figure, the applications control input and output devices. What does the figure explains you is that Zen architecture does not include any device drivers natively. Okay, it is just provide a mechanism by which a guest operating system it can have direct access to physical devices. As a result, we have to say the size of Zen hypervisor is kept rather small. Okay, Zen provides a virtual environment located between the hardware and operating system. So a number of vendors are in process of developing and commercial Zen hypervisors. Okay, so among them we have to use the Citrix Zen server and Oracle virtual machine. So here we want to develop the core components of a Zen system or hypervisor and kernel and applications. Here we have seen the organizations of three components is important like other virtualization systems. So many guest operating systems can run on top of hypervisor. Okay, however, all guest operating systems are created equal and one in particular control it to others. Okay, here we have seen the domain wo, guest domain and guest domain, and here see Zeno Linux, Zeno Windows. How we have to use Zen hypervisor. These are the hardware devices. What we have to see in the sense, the guest operating system which has control ability is called domain wo, and the others are called domain U. Domain wo is a privileged guest operating system of Zen. It is first loaded when Zen boots without any file system drives. So being available, the domain wo is designed to access the hardware directly and manage the devices. So one of the responsibility of domain wo is to allocate and map the hardware resources for the guest domains like the domain U. Okay, and coming to the one more for example, we have to these Zen architectures. Okay, for example, Zen is based on Linux and its security level is C2. For example, we have if you have take its management virtual machine is named domain O, which has the privilege to manage other virtual machines implemented on some host. Okay, if domain 0 is compromised, the hacker can control entire system. So virtual machine system security policies are needed to improve security of domain O. In domain O, it behaving as a virtual mission monitor. It allows users to create, copy, save, read and modify and share and migrate and roll back. Okay, whatever it may be, the users allows to create this. Virtual missions are easily we can handle, we can manipulate a file which which flexibly provides the tremendous benefits for whatever the users use. Unfortunately, it brings a series of security problems during software's life cycle and the data life. Okay, this is the complete information of Zen architecture. Zen is an open source hypervisor program. It is developed by Cambridge University. Zen is a microkernel hypervisor which separates the policies from the mechanism. Okay, Zen does not include any device drivers natively. It just provides a mechanism by which a guest operating system can have a direct access to the physical devices, so that the result may be the size of the Zen hypervisor is kept rather small. Zen provides a virtual environment located between the hardware and operating system. It is nothing but the Zen architecture. Later we explain in further video the binary translation with full virtualization. Okay, thank you.